is gonna be now capacitors in parallel. So hopefully you watched my video on series. I'm gonna erase all this, but I also have a video on capacitors in series if that's what you're kind of confused about, because I know the equation is kind of not really intuitive. If you're curious what the final equation is, I didn't really mention this, but it would be like 1 over C1 plus 1 over C2 plus 1 over C3 plus whatever is going to equal 1 over C equivalent. So, however many capacitors you would have, you just keep adding the reciprocal, and that sum gives you the reciprocal of the equivalent capacitor. Okay, let's talk about parallel. Let's see how that kind of plays into this whole thing. Let's just kind of blow this up, draw this a little bit bigger. So I'll do something like this. Now, so let's think about this. And once again, we can say this is 36 volts. What is going to be the same about these two capacitors? Last time in series we determined that, hey, each capacitor has the same amount of charge. What's going to be the same for the parallel? Well, it's not going to necessarily have the same amount of charge, right? Let's say there's some total amount of charge or something, right? So the total amount of positive charge, it kind of has a choice, right? It kind of has a choice to go between here and here, right? So, I mean, as soon as this fills up, then it's going to kind of have to go up here, right? When there's too much, when it's at full capacity in terms of how much charge it has. So once again, we'll call this C1, C2. So, at this instant, it kind of just has, no choice. Like it has a choice. That's what I mean. It's just got to go somewhere. Compared to a series where your positive charge, once it goes here, it's all that it can go to. So it doesn't really have that choice in a series. So the charge won't necessarily be the same. What is going to be the same is the amount of voltage in between the two capacitors, right? Because voltage is supplied by the battery, but each capacitor is connected and hooked up to the same battery. So it's going to have the same voltage. So what we can do is one statement we know is true is that whatever for our equivalent capacitor, the amount of charge it has, it's going to equal. So we'll say Q total, right, is going to equal Q1 plus Q2. Well, in this case, what we can kind of say is, okay, C1, just using our good old capacitance equation, C1 is equal to Q1 over V, and then C2 is equal to Q2 over V. What we can kind of say is, hey, I'm solving for Q1 and Q2. You would just do V times C1 is equal to Q1, right? You're just multiplying by V. And then V times C2 is equal to Q2. And this is actually a lot more simple, because now what we can do, you can kind of see where this is going. You can probably derive this. If you're doing Q1 plus Q2, that's the same as doing C1 times VC2. So V times C1 plus V times C2 is equal to Q total. And then you can divide the whole thing by V, right? You can kind of factor it out, divide the whole thing by V. So you get Q total over V is going to equal C1 plus C2. Guess what? Guess freaking what? That's this Q total over V, right? If this was if this was the equivalent capacitor, it's going to have that voltage V, right? And it's going to build up that Q total on the charge instead of having the charge kind of split up. That charge is just going to be in one spot. That's going to be our Q total. That's our equivalent capacitor. So this equivalent capacitance is C1 plus C2, and obviously if you start hooking up more and more things, you're going to have like for example Q3, right? If you have added a third capacitor plus VC3, but they all have the same thing, so you're just going to get, right? You just add up all of your parallel capacitors and you get that result. So that's actually pretty intuitive. Like, it's like, hey, if the total capacitance is, or the equivalent capacitance is going to be these two added up. That was really short. I honestly could have just added that. In fact, I don't know how to edit, so I'll figure out editing. But yeah, that's parallel capacitance. Shout out to Michael Faraday for the great question. And yeah, I'll see you guys in another video. How long was this video? Literally 5 minutes. Wow. Okay. Bye.